Hello everybody, this is Stephen Whitfield with Drilling Contractor. I am here at H&P's construction facility in Galena Park in Houston, Texas. Now, behind me is a really awesome piece of machinery, Rig 618, which was recently installed with the Flex Robotics package. Now, from the time we've shot this video, in a few weeks, this rig will be delivered out into the Permian Basin, where it will become the first rig in the lower 48 to run with an industrial robotics package. And we spoke with a couple of people from H&P, Andrew Rose and Todd Fox, about this package, the automation capabilities that it enables, and what kind of value a system like this brings for drilling contractors such as H&P. So let's check it out. So we're here with Andrew Rose of H&P on the floor of Rig 618. And we're going to be talking about the nuts and bolts of the Flex Robotics package that's been installed. So, Andrew, thank you so much for joining me today.
Yeah, of course. Thanks for having me.
So, at the heart of this package are these three robotic arms. We see one of them behind us here. There are a couple that are a little bit out of frame. Can you tell us a little bit about those arms and sort of some of the other stuff that you guys have installed here as part of this package?
Yeah, the core of the robot system are the three robotic arms that you just talked about. Those robotic arms are not a custom deal. That we're utilizing industry-proven robotic systems. They're highly reliable, but just tailored for our application here. The idea there is that we've got years and years of industry experience for those, so that what we're delivering is a very highly reliable system that doesn't require a lot of maintenance.
So let's talk a little bit about the automation side of this. I mean, obviously, this system is something that sort of augments some of the stuff that you guys are doing with automation. How does that all work together?
Yeah, so H&P already has right now what we're calling our Rig 4 automation package, and that utilizes the hex grip, which is a step up from what we've been using in the past as far as an iron roughneck goes. It's also utilizing our retracting slip lifters, and both of those devices remove people off of the machinery or off of the rig for those operations. So we don't have people having to pull slips. We don't have somebody operating the iron roughneck locally. All that can be done inside the driller's cabin. The robotics package just builds on top of that, with the goal of removing people completely off the rig for all necessary tasks associated with tripping connections or drilling connections.
Now, it's interesting that you bring up removing people from things and having people not do things, because that makes me think of safety.
Yeah.
Now, we are in an area that typically when all this stuff is running, we wouldn't be here. We have some barricades and things like that. What kind of safety barriers have you guys put in place to make sure that as all this stuff is running, nobody's getting hurt?
Yeah, we are right in the middle of the robotic workspace. So if this thing was on, this would be probably the worst place for us to be. Safety is the core of what we were doing from the very beginning of this project. The idea to remove people away from well center, away from moving equipment, out from under the derrick, was one of the #1 reasons that we were even doing this. But we also want to make sure that nobody enters into the rig 4 by accident, or if they forgot something, none of those let me just real quick type of situations. So we've got a couple systems in place for that. One is a barricade system, so that nobody can enter the rig 4 unless you open a gate. Those gates have sensors integrated into them, so if you open it at all, it e-stops the whole robotic system. We've got e-stop buttons right outside those gates to be able to physically just slap a button if you need to e-stop the system. We also have a computer vision system that looks at the robotic workspace and looks for and detects humans that could be inside that area, and would prevent you from coming out of an e-stop state if it detected a human inside the robotic workspace.
Now, we were in the driller's cabin a little bit earlier as we were looking at all of this and looking at sort of the interface that the driller has to look at. And it seems like when it comes to implementing a system like this, sort of the ease of use must be a top priority. What kind of adjustments did you have to make with the interface to make it to where the driller can come in, do one hitch, and they've got this thing down?
Yeah, it's a great question. There's a lot of complexity to this system. We have tailored our screens that the drillers use every day to integrate the main robotics controls onto that screen to make the touch as light as possible for the driller. We've also changed out our joysticks to give more tactile feedback to the driller, so he's not having to look over at a screen and hunt for a button. He can get in a groove, get his hands on those joysticks, and know the buttons he needs to push without having to take his eyes away from the action that's happening on the rig floor. So the learning curve is not that bad for the drillers. One hitch will get them up to speed on how to use the robotic system. There's as much detail as you want to get into on the screens. If you need to dig into the diagnostics, you can dig into the diagnostics. But for the use of the system, it's pretty light. There's only a few buttons that he has to really work with.
And lastly, I mean, you're incorporating a lot of complexity here, a lot of complexity to make it simple, I guess, that makes any sense. And I would imagine that when you're incorporating robotic arms with your systems, controls, things like that, that there would be some challenges with that integration, maybe on a coding side, maybe on other things. What kind of challenges have you seen in melding all these things together, and how have you guys sort of addressed that?
Hardware was not as much of an issue as the control system was for us on this first application. In our partnership with NOV, we realized that we needed to make a pretty significant controls change about halfway through the development of this, and that controls change was pretty significant. It was, we're changing out all the computers, we're reprogramming from the ground up, but it was a necessary thing that we needed to do. We just couldn't get past the robustness and performance hurdles that we were seeing at the beginning. But after that control system change, we're absolutely right where we want to be.
Okay, we're here with Todd Fox of H&P to talk a little bit more about this Flex Robotics package. So Todd, thank you so much for joining me.
Oh, thanks for coming here today, Stephen.
Well, let me talk a little bit from a broader perspective here. And you look at all of this stuff, all this cool stuff that you've put onto this rig, the first question that comes to my mind is why? So what is the motivation for H&P to engage in installing a package like this?
So within H&P, one of the core values is safety by design. And throughout the rig, from the birth of the Flex rigs until now, it's been an evolution of improvements in technology and design to reduce risk, while also delivering peak performance. And robotics we see as another tool in that toolbox of improvements to the Flex rig design.
It's interesting that you say peak performance, because I would think about what kind of value H&P sees specifically in this. Is performance really where we see the value with a system like this?
Performance matters. Our customers are keenly aware of the efficiency that H&P brings to the table. We knew that with new technology, we couldn't sacrifice in the performance area. So we set an objective of delivering a new technology package that would be on par with the current average crew performance and with a pathway to improve it further.
So we have a few crew members out here that we've met as we visited this site, and you've been quick to emphasize that even though this system incorporates some automation, augments some automation that you guys are already working on, that the crew still matters. There's still people here operating. So I guess my question then would be, how does the role of the crew change? Where does the human fit within a system like this?
The crew is critical. They're a critical component of what drives value within H&P. What we love about robotics is it'll be a force multiplier for that crew. So instead of a significant portion of the crew up on the floor for tripping in, out of the hole, for making connections, they're prepping for the next evolution of the rig. So they're focused entirely on the flat times, preparing to run casing, preparing to nipple up and test, preparing to walk the rig, preparing for a rig move, to lay down pipe. They're laser focused on that, and they're going to have a lot more energy because they won't have just finished tripping pipe for 12 straight hours.
One word I didn't hear you say was maintenance. Now, you had mentioned before as we visited this rig site that the maintenance on a system like this is so much less of a burden. for the crew here. Can you talk a little bit more about how that all works?
Sure. So the robotic arms themselves are very maintenance friendly. There's new maintenance that the crew will that we brought up to speed in our R&D test rig up in Tulsa. And so the maintenance requirements are well understood and are being done on a daily basis as these rigs were built and delivered. And so they'll carry that on, but the rest of the rig equipment, they'll have a lot more time to devote to it in terms of prepping all the mud pumps so that there are no issues when we go back to drilling or when we begin a flat time activity.
So as we shoot this video of this system, this rig is going to be delivered out into the Permian shortly after we've shot this, but you wouldn't do something like this for just one rig. Why would anyone bother? So what are the future plans for this system? How are we scaling this up?
That's right. We're super excited to put this rig to work for a super major in the Permian Basin. It's our largest operational basin. H&P is about scale, about uniformity, technology, scale, and performance. And so we want to come out of the gate. We've got a great super major operator. We've got a great partner with NOV. We've got to show the value that the system should be capable of delivering. And then to truly make it economical in the long term, we have to get scale. And fortunately, the super major we're working for is been really on board with that and been open to having other operators come out to the rig. We know it has to be more than just one operator, and as we get scale, we'll drive the economics down, and that'll make the system that much more attractive to other operators.
So I'd like to thank Andrew and Todd for taking the time to speak with us about the Flex Robotics package. We're looking forward to more stuff from them in the future. This is Stephen Whitfield with Drilling Contractor. Be sure to check out our September-October edition in print and digital, where we talk more about the Flex Robotics package installation and what it means for H&P in the future. Thank you very much for visiting drillingcontractor.org.